In this tutorial, we will see how to compute the tracking signal using the standard approach. This is the approach used by most textbooks. If you have not done so, please review the introductory tutorial first. The slide shows a set of data for periods 1 through 10 and an associated forecast. We wish to compute the tracking signal for this forecast and see if there is any bias. 3 notes about this forecast. First, this is the first simple regression forecast example from a prior tutorial, although that will not affect the calculations. Second, the forecast has been rounded to whole numbers to simplify the calculations. The impact on the resulting tracking signal of the rounding will be minimal. And third, we have not shown the forecast beyond period 10. Calculating the tracking signal requires both an actual and a forecast value in each period, so a tracking signal cannot be computed for a period with just a forecast or just an actual value. The slide shows a chart of the actual and forecast values. Notice that the two are very close and that the forecast in orange is sometimes above and sometimes below the actual values in blue. Therefore, we do not expect to find bias. The calculations will require the following 6 columns. The actual minus forecast value for this period. The absolute value of the actual minus forecast value just computed for this period. The cumulative actual minus forecast value through this period. The cumulative absolute value of the actual minus forecast value through this period. The MAD through this period. The tracking signal for this period. The calculations for period 1 are slightly different than the remaining periods. That difference only affects the 2 cumulative columns. For period 1, 125 minus 127 equals negative 2. The absolute value of negative 2 is positive 2. For period 1 only, the cumulative actual minus forecast column equals the actual minus forecast value of negative 2 computed earlier. For period 1 only, the absolute value of the cumulative actual minus forecast column equals the absolute value of the cumulative actual minus forecast value of 2 computed earlier. The MAD is just the absolute value of the cumulative actual minus forecast column divided by 1, or 2.00 in this case. A quick note about calculating the MAD is in order. Not all forecasting techniques produce a forecast for period 1. When there is a forecast for period 1, as we have here, the MAD is just the cumulative actual minus forecast column divided by the period number. If the forecast starts in any period other than 1, then the first MAD is divided by 1, the second by 2, and so on. We will see this in the next example. The tracking signal is the cumulative actual minus forecast column of negative 2 divided by the MAD of 2.00, or negative 1. For period 2, the calculation of the 2 cumulative columns will change slightly. The remaining calculations will remain the same. 130 minus 133 equals negative 3. The absolute value of negative 3 is positive 3. The cumulative A minus F value from the last period of negative 2 plus the current A minus F value of negative 3 equals negative 5. The cumulative absolute value of A minus F value from the last period of 2 plus the current A minus F absolute value of 3 equals 5. The MAD is the cumulative absolute value of A minus F of 5 divided by 2 equals 2.5. The tracking signal is the cumulative A minus F value of negative 5 divided by the MAD of 2.5 equals negative 2. For period 3, 141 minus 138 equals 3. The absolute value of 3 is 3. The cumulative A minus F is negative 5 plus 3 equals negative 2. The cumulative absolute value of A minus F is 5 plus 3 equals 8. The MAD is the cumulative absolute value A minus F value of 8 divided by 3 equals 2.67. In this tutorial, all calculations are rounded to 2 decimal points. Finally, the tracking signal is the cumulative A minus F value of negative 2 divided by the MAD of 2.67 equals negative 0.75. For period 4, 142 minus 143 equals negative 1. The absolute value of negative 1 is 1. The cumulative A minus F is negative 2 plus negative 1 equals negative 3. The cumulative absolute value of A minus F is 8 plus 1 equals 9. The MAD is the cumulative absolute value of A minus F value of 9 divided by 4 equals 2.25. Finally, the tracking signal is the cumulative A minus F value of negative 3 divided by the MAD of 2.25 equals negative 1.33. For period 5, 150 minus 148 equals 2. The absolute value of 2 is 2. The cumulative A minus F is negative 3 plus 2 equals negative 1. The cumulative absolute value A minus F is 9 plus 2 equals 11. The MAD is the cumulative absolute value A minus F value of 11 divided by 5 equals 2.20. Finally, the tracking signal is the cumulative A minus F value of negative 1 divided by the MAD of 2.20 equals negative 0.45. For period 6, 157 minus 153 equals 4. The absolute value of 4 is 4. The cumulative A minus F is negative 1 plus 4 equals 3. The cumulative absolute value A minus F is 11 plus 4 equals 15. The MAD is the cumulative absolute value A minus F value of 15 divided by 6 equals 2.50. Finally, the tracking signal is the cumulative A minus F value of 3 divided by the MAD of 2.5 equals 1.20. For period 7, 157 minus 158 equals negative 1. The absolute value of negative 1 is 1. The cumulative A minus F is 3 plus negative 1 equals 2. The cumulative absolute value A minus F is 15 plus 1 equals 16. The MAD is the cumulative absolute value A minus F value of 16 divided by 7 equals 2.29. Finally, the tracking signal is the cumulative A minus F value of 2 divided by the MAD of 2.29 equals 0.87. For period 8, 164 minus 163 equals 1. The absolute value of 1 is 1. The cumulative A minus F is 2 plus 1 equals 3. The cumulative absolute value A minus F is 16 plus 1 equals 17. The MAD is the cumulative absolute value A minus F value of 17 divided by 8 equals 2.13. Finally, the tracking signal is the cumulative A minus F value of 3 divided by the MAD of 2.13 equals 1.41. For period 9, 167 minus 168 equals negative 1. The absolute value of negative 1 is 1. The cumulative A minus F is 3 plus negative 1 equals 2. The cumulative absolute value A minus F is 17 plus 1 equals 18. The MAD is the cumulative absolute value A minus F value of 18 divided by 9 equals 2.00. Finally, the tracking signal is the cumulative A minus F value of 2 divided by the MAD of 2.00 equals 1.00. For period 10, 171 minus 173 equals negative 2. The absolute value of negative 2 is 2. The cumulative A minus F is 2 plus negative 2 equals 0. The cumulative absolute value A minus F is 18 plus 2 equals 20. The MAD is the cumulative absolute value A minus F value of 20 divided by 10 equals 2.00. Finally, the tracking signal is the cumulative A minus F value of 0 divided by the MAD of 2.00 equals 0.00. Since none of the tracking signals are outside of the plus or minus 4 range, there is no bias. The slide shows a set of data for periods 1 through 10 and an associated forecast. We wish to compute the tracking signal for this forecast to see if there is any bias. 4 notes about this forecast. First, this is a simple moving average forecast example from a prior tutorial, although that will not affect the calculations. Second, unlike the first example, the forecasts have not been rounded. Third, we have not shown the forecast beyond period 10. The reasoning for this was explained in the prior example. And fourth, since this was a 4-period simple moving average, there is no forecast values for periods 1 through 4. That means we will not be able to use them in the tracking signal calculations. The only change that will make is when we calculate the MAD for period 5, we will divide by 1 rather than 5 since it is the first forecast. Likewise, for period 6, we will divide by 2, for period 7 by 3, and so on. The slide shows a chart of the actual and forecast values. Notice that the forecast in orange is always below the actual in blue. Therefore, we expect to find significant bias. Since we are introducing new material with this example, you do not need to pause the video and work the example first. You can do that with the next example. However, if you wish to pause the video and attempt this, feel free to do so. The actual of 150 minus the forecast of 134.50 equals 15.50, and its absolute value is 15.50. Since this is the first period for the tracking signal, the cumulative A minus F also equals 15.5, as does the cumulative absolute value A minus F. The MAD is 15.50 divided by 1, not 5, which equals 15.50. The tracking signal is 15.50 divided by 15.50 equals 1.00. For period 6, 157 minus 140.75 equals 16.25. The absolute value of 16.25 is 16.25. The cumulative A minus F is 15.5 plus 16.25 equals 31.75. The cumulative absolute value A minus F is 15.5 plus 16.25 equals 31.75. The MAD is the cumulative absolute value A minus F value of 31.75 divided by 2 equals 15.88. Finally, the tracking signal is the cumulative A minus F value of 31.75 divided by the MAD of 15.88 equals 2.00. For period 7, 157 minus 147.5 equals 9.5. The absolute value of 9.5 is 9.5. The cumulative A minus F is 31.75 plus 9.5 equals 41.25. The cumulative absolute value A minus F is 31.75 plus 9.5 equals 41.25. The mat is the cumulative absolute value A minus F value of 41.25 divided by 3 equals 13.75. Finally, the tracking signal is the cumulative A minus F value of 41.25 divided by the mat of 13.75 equals 3.00. For period 8, 164 minus 151.5 equals 12.5. The absolute value of 12.5 is 12.5. The cumulative A minus F is 41.25 plus 12.5 equals 53.75. The cumulative absolute value A minus F is 41.25 plus 12.5 equals 53.75. The mat is the cumulative absolute value A minus F value of 53.75 divided by 4 equals 13.44. Finally, the tracking signal is the cumulative A minus F value of 53.75 divided by the mat of 13.44 equals 4.00. For period 9, 167 minus 157 equals 10. The absolute value of 10 is 10. The cumulative A minus F is 53.75 plus 10 equals 63.75. The cumulative absolute value A minus F is 53.75 plus 10 equals 63.75. The mat is the cumulative absolute value A minus F value of 63.75 divided by 5 equals 12.75. Finally, the tracking signal is the cumulative A minus F value of 63.75 divided by the mat of 12.75 equals 5.00. For period 10, 171 minus 161.25 equals 9.75. The absolute value of 9.75 is 9.75. The cumulative A minus F is 63.75 plus 9.75 equals 73.5. The cumulative absolute value A minus F is 63.75 plus 9.75 equals 73.5. The mat is the cumulative absolute value A minus F value of 73.5 divided by 6 equals 12.25. Finally, the tracking signal is the cumulative A minus F value of 73.5 divided by the mat of 12.25 equals 6.00. Several of the tracking signals exceed positive 4, which indicates bias. This pattern of the tracking signal being 1.00, 2.00, 3.00, 4.00, and so on happens anytime the forecast is always below the actual. If the forecast were for a longer period and stayed below the actuals, the numbers would continue to increment. It is this incrementing that causes the tracking signal to exceed the +4 value and signal bias. Had all of the forecasts been above the actuals, then the tracking signal would have been -1.00, -2.00, -3.00, and so on. Of course, it would be unusual for a forecast to always be completely above or below the actuals. So, you usually do not see them in a linear pattern. However, when they are mostly above or below, the values do tend to ratchet up or down and thus signal bias. The slide shows a set of data for periods 1 through 10 in the associated forecast. We wish to compute the tracking signals for this forecast and see if there's any bias. This is the same actuals we used for the prior two forecasts, only with a new forecast. The slide shows a chart for the actuals and forecast values. While the forecast in orange is sometimes above the actuals in blue, it is mostly below the actuals, so we anticipate bias being an issue. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. There is no forecast for period 1, so our calculations will begin in period 2. As before, the first MAD value is divided by 1, the second by 2, and so on, and not by the period number. For period 2, 130 minus 125 gives us 5.00, which has an absolute value of 5.00. Since this is the first period, the cumulative A minus F value is 5.00, as is the cumulative absolute value A minus F value. The MAD is the cumulative absolute value A minus F value of 5.00 divided by 1 equals 5.00. Finally, the tracking signal is the cumulative A minus F value of 5.00 divided by the MAD of 5.00 or 1.00. For period 3, 141 minus 126.8 equals 14.2. The absolute value of 14.2 is 14.2. The cumulative A minus F is 5 plus 14.2 equals 19.2. The cumulative A minus F is 5 plus 14.2 equals 19.2. The cumulative absolute value A minus F is 5 plus 14.2 equals 19.2. The MAD is the cumulative absolute value A minus F value of 19.2 divided by 2 equals 9.60. Finally, the tracking signal is the cumulative A minus F value of 19.2 divided by the MAD of 9.60 equals 2.00. For period 4, 142 minus 131.96 equals 10.04. The absolute value of 10.04 is 10.04. The cumulative A minus F is 19.2 plus 10.04 equals 29.24. The cumulative absolute value A minus F is 19.2 plus 10.04 equals 29.24. The MAD is the cumulative absolute value A minus F value of 29.24 divided by 3 equals 9.75. Finally, the tracking signal is the cumulative A minus F value of 29.24 divided by the MAD of 9.75 equals 3.00. For period 5, 150 minus 135.76 equals 14.24. The absolute value of 14.24 is 14.24. The cumulative A minus F is 29.24 plus 14.24 equals 43.48. The cumulative absolute value A minus F is 29.24 plus 14.24 equals 43.48. The MAD is the cumulative absolute value A minus F value of 43.48 divided by 4 equals 10.87. Finally, the tracking signal is the cumulative A minus F value of 43.48 divided by the MAD of 10.87 equals 4.00. For period 6, 157 minus 141.14 equals 15.86. The absolute value of 15.86 is 15.86. The cumulative A minus F is 43.48 plus 15.86 equals 59.34. The cumulative absolute value A minus F is 43.48 plus 15.86 equals 59.34. The MAD is the cumulative absolute value A minus F value of 59.34 divided by 5 equals 11.87. Finally, the tracking signal is the cumulative A minus F value of 59.34 divided by the MAD of 11.87 equals 5.00. For period 7, 157 minus 157.2 equals negative 0.2. The absolute value of negative 0.02 is 0.2. The cumulative A minus F is 59.34 plus negative 0.2 equals 59.14. The cumulative absolute value A minus F is 59.34 plus 0.2 equals 59.54. The MAD is the cumulative absolute value A minus F value of 59.54 divided by 6 equals 9.92. Finally, the tracking signal is the cumulative A minus F value of 59.14 divided by the MAD of 9.92 equals 5.96. This is the first time the forecast is above the actual, although just slightly above. As a result, the tracking signal does not go all the way to 6.00. The further the forecast is above the actual, the less the tracking signal increases. If the forecast were significantly greater than the actual in this period, the tracking signal would in fact decline. For period 8, 164 minus 171.18 equals negative 7.18. The absolute value of negative 7.18 is 7.18. The cumulative A minus F is 59.14 plus negative 7.18 equals 51.96. The cumulative absolute value A minus F is 59.54 plus 7.18 equals 66.72. The MAD is the cumulative absolute value A minus F value of 66.72 divided by 7 equals 9.73. Finally, the tracking signal is the cumulative A minus F value of 51.96 divided by the MAD of 9.53 equals 5.45. The forecast is above the actual again and the tracking signal declines again. For period 9, 167 minus 166.29 equals 0.71. The absolute value of 0.71 is 0.71. The cumulative A minus F is 51.96 plus 0.71 equals 52.67. The cumulative absolute value A minus F is 66.72 plus 0.71 equals 67.43. The MAD is the cumulative absolute value A minus F value of 67.43 divided by 8 equals 8.43. Finally, the tracking signal is the cumulative A minus F value of 52.67 divided by the MAD of 8.43 equals 6.25. The forecast is below the actual value this period, and so the tracking signal increases again. For period 10, 171 minus 172.69 equals negative 1.69. The absolute value of negative 1.69 is 1.69. The cumulative A minus F is 52.67 plus negative 1.69 equals 50.98. The cumulative absolute value A minus F is 67.43 plus 1.69 equals 69.12. The MAD is the cumulative absolute value A minus F value of 69.12 divided by 9 equals 7.68. Finally, the tracking signal is the cumulative A minus F value of 50.98 divided by the MAD of 7.68 equals 6.64. Several of the tracking signals exceed plus or minus 4, indicating bias.
If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.